Alright, I want to do a couple more examples for implicit differentiation. Here's a popular question you can be asked. If you have an implicit function and they want to know at the point 1 comma negative 3, what is the equation of the tangent line? So when you're asked that, if you want the equation of a line, there are two things you need. You need a point and you need the slope. Alright? They gave us the point. It's 1 comma negative 3. We need the slope. In order to find the slope, you have to find the derivative of y with respect to x. Another word for slope is derivative. And so we have to take the derivative of this function up here at the top. So we're going to take the derivative of the left with respect to x and the derivative of the right with respect to x. And so when we do that, we get 0 on the right side equals, take the derivative just like usual, we have 3y squared, but the variables did not match, so we have to have a dy over dx plus 2y. Again, the variables do not match. Minus, I think I'm going to run out of room here, minus 5, the variables didn't match, dy dx, minus, our variables do finally match, so we just take the derivative there like usual. That's all it takes, and that equals 0. We need to add 2x to both sides if we want to get dy dx by itself. So we'll be left with 3y squared dy dx plus 2y dy dx minus 5 dy dx equals 2x. Again, you can see they all have a dy dx, so we can factor that out. And then you're left with 3y squared plus 2y minus 5 equals 2x. Divide both sides to get dy dx by itself. And so we'll have 2x on the top. And then we're going to divide by the entire other piece, 3y squared plus 2y minus 5. Gives us our derivative. Now we're not quite done because we want to know the derivative at this point. We need the slope at that point in order for us to find the tangent line. And so what we have to do now is we have to take our function dy dx and evaluate it, that's the evaluation sign, at this point, 1 comma negative 3, which simply means we're going to plug in x and we're going to plug in y. So we're going to have 2 times 1, it's nice and easy, all over 3 times y squared plus 2 times y minus 5. Then we'll have 2 over negative 3 squared is 9, times 3 is 27, minus 6, minus 5. 27 minus 11 is 16, which equals 1/8. So we just found our slope is 1/8. Now we can make the equation. Y minus the value of y, which is negative 3, equals the slope of 1/8 times x minus 1. That is perfectly fine. You do not need to simplify that for the purposes of the AP test, so we may as well leave it there. That is the equation of the tangent line. Alright, one more I want to go over. A little bit harder than that one. So we're just going to do the implicit differentiation here. So, our last equation here is x cubed minus xy plus y squared equals 7. There we are. And we want to find dy dx. What is the derivative of y with respect to x? So I'm hoping something glares out at you right here. That is x times y. If we have two variables that are multiplying each other, we are going to have to use a product rule. So when we take the derivative, let me use a different color here. When we take the derivative of the left with respect to x and the derivative of the right with respect to x, we are going to have to remember that this will be a product rule. Let's start doing that. First, our variables match. X cubed becomes 3x squared. I'm going to do the outside too. Do the easy stuff first. Y squared becomes 2y dy dx equals, and the derivative of 7 is 0. But now we've got to do this pesky product rule in the middle. So if you remember the product rule, the derivative of the first, which is going to be negative 1 times the second, plus the derivative of the second. So when I take the derivative of the y, you'll notice that will not match in terms of variables. So that's going to be the derivative of y is 1 dy dx times the second. The second is negative x, and then plus our third term there. So that in the middle was our product rule. Let's keep going. If we want to get dy dx by itself, we need to at least get rid of 3x squared. We're going to have to get rid of y also. I think that's it. So minus 3x squared plus y on that side. So we'll be left with negative x dy over dx. I just move that to the front. Plus 2y dy dx equals negative 3x squared plus y. We can factor out our dy dx times negative x plus 2y is left over. The right side stays the same. And then we can divide both sides by negative x plus 2y. I almost said squared there. That would have been bad. Alright, same thing here, negative x plus 2y. That goes away. So dy over dx equals negative 3x squared plus y over negative x plus 2y. And so there we have our dy dx solved for. One thing you want to be careful of, I've seen this a lot, you might be very tempted to cancel out the negatives and turn them into positive. You are not allowed to do that right here. Unless you factored that negative 1 out, then you could do it. So it would have to look something like negative 1 times 3x squared minus y over negative 1 times x minus 2y. Then you could cross out the negatives, and that's what you would be left with. But you cannot cross them out just because the leading coefficient is negative. It's a common mistake I see. Be careful not to do that. So that gives you an example of a implicit derivative where you have a quotient rule in it as well. Those come up a lot, so you want to make sure you see how that works and be careful that you use the product rule.